So let's start off with pores. So pores are very nice in terms of they are usually very fast. However, they're not regulated in quite the same way. In fact, usually when they are inserted in the cell membrane, they are open. Although you can modulate this a little bit from time to time with protein-protein interactions. So think of this a lot like a funnel. You have a funnel in the cell membrane, you pour something like water into it, and it moves directly through that cell membrane. Now, ocuporins are these water molecules, and they are located in different types throughout the body. There are 13 primary types of ocuporins, and we label those from 0 to 12. And they are in various densities in different tissues. So, adipocytes, or fat cells, have this ocuporin 7 in them. Blood have more specific type of ocuporins, 1, 3, and 9. The central nervous system, or brain, has 1, 3, 4, and 5. The skin has ocuporin 3. Skeletal muscle uses ocuporin 4. The lungs use 3, 4, and 5. And finally, the kidney uses 1, 2, 3, 4, and 7. We're going to spend the prototype time in this particular pore talking about ocuporin 2, which is located primarily in the kidney. So how do ocuporin 2s work? Well, these are going to be water channels. And in the kidney, you want to move water from the apical membrane, or from the apical lumen side across the apical membrane into the cell. This allows you to reabsorb water. Why do you want to reabsorb water? So you don't dehydrate, so you can have as much water within the system as you can. If you don't reabsorb water, you will end up peeing it or urinating it out. How do these work? These are all in the apical membrane here, allowing water transport to move. But you need to have an osmotic gradient for water to move. What determines water transport is basically the density of ocuporin 2 channels on this membrane. The more channels you have, the more water will move if you have an osmotic gradient. The less channels you have, the less water will move if that gradient exists. How do you regulate the amount of ocuporin channels? It's primarily by a vesicle membrane insertion. So, in response to a stimulus, in this case, it's using antidiuretic hormone, also known as arginine vasopressin. You signal these vesicles with ocuporins in them to fuse within the membrane of that apical side of the cell. It has in it ocuporins. So how you regulate this is you just bud and insert this particular vesicle within that apical membrane, and that increases the density of cell transporters. How does this process work? Can be seen here, where you need to have binding of this arginine vasopressin to a particular receptor, and then through a signaling process, you will both make more ocuporin 2 and cause phosphorylation of various proteins to make these vesicles dock and fuse on the apical membrane. And this is how this kind of pore system works, and how ocuporin 2 channels importantly affect body fluid balance in the kidney.